Hello from the OPC Foundation. I'm really excited that we are kind of back. The OPC Foundation is back here at the ACHEMA Pulse. Remember, the OPC Foundation initiative started in the process industry. At the beginning, it was only for process control, long time ago. Now we are working and continue the success of OPC Unified Architecture, which is completely independent from any operating system, and it stands for openness, productivity, and communications. And I'd like to share you more information here at the ACHEMA Pulse. So my presentation is just here as a starter, but after that we have a fantastic agenda with details on activities on the field level. We have standardized information models. Frank Fengler from ABB gives us a 15-minute overview on PA-DIM and the status, but also there are a lot of other excitements on other information models, and we get a small teaser from all of them. We are talking about artificial intelligence in the process industry, and we have Erich Barnstedt. How do you connect your assets to the Microsoft Azure cloud in general, how to avoid any vendor lock-in into the cloud systems. On day 2, I'm excited to have speakers from Dr. Jörg Henniche and Andreas Henneken from introducing that all information about Ethernet APL. We have a fantastic live demonstration with companies like Endreshauser, Pepperle Fuchs, and Samsung and Microsoft. And we are moving data via Ethernet APL and OPC and PA-DIM up into Microsoft dashboards. So we have another demo and commitments from ABB and Beckhoff, so I'm really excited on that. You shouldn't miss that demonstration. After that, we have how to migrate from the today's world into the modern world with Mike Clark. We have success stories from Equinor connecting 190,000 data points to the Microsoft Azure cloud again. And we learn from SAP about the convergence of IT/OT in the process industry. Last but not least, it's our friend Don Bartusiak from the OPAS group, and he's talking about the Open Process Automation Control System and why his group selected OPC and what is a benefit, and also his expectation what OPC needs to deliver and so on. I believe this is a really fantastic program. Last but not least, we are offering 3 workshops. If you want to dive into the details and you want to learn more about basic information models, please connect to the OPC for machinery. This is with including live demo. It's real, it's existing. Second, we have a live demo again on how to connect your assets to the Azure cloud within 45 minutes. And third, we have a workshop on certification, including OPC, but also all the information models. OPC, the challenge here is really to move from the old traditional automation pyramid with all the different proprietary layers to a new modern information network where you can exchange information from the field up into the cloud. You can bypass layers, but it's always about focusing on standardized information which you are able to exchange in an end-to-end secured way. This is what we are doing, and this is what the OPC framework is doing, because remember, OPC is not just a protocol. Instead, it's all about modeling data, the standardized data, what we do together with partners, and then have different IT infrastructure where we can transport over different IT layers like TCP, UDP, like MQTT, because there's not one single protocol which is fulfilling all requirements from the OT to the IT world. Sometimes you need deterministic, sometimes you have more cloud scenarios, and so we need a way how can we exchange data without any media break from the field up to cloud and back. In my presentation today, I will talk about the 5 building blocks, which I believe it's important for the process industry. It's number 1, the UA technology itself, the framework. It's number 2, the largest ecosystem for industrial interoperability. It's 3 legal topics and aspects. It's 4 the extensibility. We just joined the Ethernet APL initiative. And number 5, how do we guarantee to standardize information? Well, who are our partners? What is the process? So let's talk about the ecosystem, the OPC Foundation. We are proud to have more than 820 members around the world. The vision is to exactly provide a secure, reliable, completely independent platform, independent from any vendor, from any operating system, from any market, to scale data from the field up to the cloud and back. And everything what we deliver is open. Specifications, once they are released, are open, available. You don't have to be a paying member. We provide sample code free of charge on GitHub. Our certification labs are open. You don't have to be a paying member of the OPC Foundation. Obviously, you pay your daily fees. And we are proud to have really the largest ecosystem, including toolkits, education, vendors. We have an academic program and so on. So here you see that OPCUA is not just about vendors in the automation world. Instead, it scales from hyperscalers and IT companies down to chipset vendors. A lot of end users we are very proud on, and they are also delivering success stories and share their success and what have been the reasons why they have selected OPCUA. So this is definitely what we are very proud on. Being a paying member inside the OPC Foundation guarantees you early information and you are able to influence the direction. Part of our community is with more than 300 technical experts from more than 60 companies, the so-called Field Level Communications Initiative, which is bringing OPCUA down to the field, including deterministic, including functional safety and motion, but also harmonizing between the process industry and the factory automation world. This is what we need. And I'm looking forward to have the first live demo at this year's SPS show in November 2021. The OPC Foundation joined the Ethernet APL initiative in 2022 because we believe that exactly OPCUA in combination with Ethernet APL is really a common sense partnership between 2 enabling technologies, and it will be influencing the market for the next decades to come. Ethernet APL is definitely a perfect enabler because it's bringing standardized Ethernet-based IT infrastructure from edge down to the field, to the sensor actuator level. And so APL is an enabler for OPCUA, plus what I explained just before with OPCUA FX, the field exchange specification set. I'm not talking deeply about OPCUA here, but again, it's open, it is open source, it is an IEC standard, it is vendor neutral, platform neutral, neutral and independent from any operating system. It is not a protocol. Instead, it has modeling capabilities to design and model your information, bring them into a context, and then have inside the body multiple different protocols which also can be extended for future need, but then deliver an end-to-end secured data exchange. This is what we believe is critically important. Security has been baked in by design and has been reviewed by international security experts. If you think more in pictures, then let's say OPCUA is a set of technology bricks, like here Lego bricks maybe is a good example. And there are multiple bricks with different focus for discovery, connectivity, security, different transport protocols, modeling capabilities, and so on. And if we talk about companion specifications, what I do in a few seconds, then this is kind of a package where you put where you select which kind of bricks do I need to describe a robot, a pump, whatever, and what kind of bricks are mandatory and which are optional. And so this makes it easier for end users to just order, I want to have a robot supporting the robot information model, or I'm no longer buying any pump, the pump must deliver the OPC for pump's companion specification. The combination of both deliver industrial interoperability. Well, I'm an engineer, not a legal person, so I'm a little bit more carefully here, but what we are very proud on is that the OPC Foundation is not only protecting their own members, instead we are protecting and have a commitment to take care on all implementers. That's critically important, and I think this is really unique. You don't find that many organizations on the market. And second, we are extremely proud on our so-called multi-organization collaboration agreement, the MOCA, because this enables really owners to easily agree on being a co-owner. Here, for example, we are really excited that the Lutz companion specification for laboratory and analyzer device standard just extended the ownership, which initially has been created by SPECTARIS, VDMA, and OPC Foundation, now to multiple other associations. And so everybody feels being involved, everybody is committed, and this is how we can grow standards in the world. We need to work together, but we have to agree on the most open approach. We are partnering with a lot of associations around the world. Definitely there's not a chance here to highlight a few of them, but please go to our web and have a detailed overview. As mentioned, we have over 63 collaborations international. In total, 48 companion specifications are published already as a released specification or available as a release candidate right now. So please go to the web and have a detailed overview. For me, it's a pleasure to announce that we have been able to work on a multi-vendor demo, including the newest technologies like Ethernet APL, like OPC, including PA-DIM, and move data from multiple vendors like Anderson Hauser, Pepperle Fuchs, and Samsung devices up into a Microsoft Azure dashboard. So please join the demo, which will be explained tomorrow in deep detail. Second, we also got a explanation and demonstrator from ABB about the combination of OPC with Ethernet APL. If you want to learn more about a real-world success story and what have been the benefits of OPC and why the company Equinor have selected this, please join the detailed report from Equinor, and they are giving much more detail how they have been connected 190,000 data points to OPC via OPC through the Microsoft Azure cloud, and they are even extending it up to 1 million data points. This is a slide I started at the beginning, explaining the 5 building blocks in detail. It's OPC, the framework, which is more than just a protocol because it includes the capability of information modeling for semantic interoperability. It includes security for an end-to-end security. We are the largest ecosystem for secure industrial interoperability, including the field level communication initiative, bringing OPC down to the field level, including deterministic, functional safety, motion. We have one of the most open IPR policies in the world, protecting also implementers, not only doing a commitment to our own members. We joined the Ethernet APL initiative because the OPC technology is extendable, same as we are extending it for the factory automation people with TSN and other technologies, or with 5G, to also guarantee that we can have a chained transport paths with multiple different infrastructures, but that we guarantee a complete quality of service over different transport technologies. Plus, I talked about all our collaboration efforts in a most open way. We are working with so many organizations, but we are also harmonizing all the efforts, that not everybody has its own MES interface and its own power management interfaces does not make any sense. This is why we are spending a huge effort to harmonize activities in both the process and the factory automation world. Together, all this comes together, including frameworks which are designed for the process industry, like the OPAS framework or the Namur Open Architecture framework. That was my introductional overview presentation. I hope you enjoyed it and you got some insights and maybe you had some additional information. Again, I'd like to invite you to all the offerings here at the ACHEMA Pulse. We have multiple presentations on the technology, on information model, or how to move data from the field vertical up to IT and cloud, to Microsoft or SAP from our both board colleague companies. Otherwise, please join our multi-vendor demo for next year. This is an announcement for 2022. The OPC Foundation already booked and we are committed to ACHEMA in 2022 in April. We booked a large space, more than 300 square meters, because we want to build a huge multi-vendor demo, including a lot of more vendors and solutions where devices interact with each other, but also move standardized data up into different IT and cloud systems, including end-to-end security. This is what we want to celebrate in April 2022. So please contact us. Thank you for your attention. Stay healthy. Bye-bye.
Hello and welcome to my presentation here at the ACHEMA Pulse about extending OPC UA to the field. My name is Peter Lutz. I am the responsible director for the Field Level Communications Initiative as part of the OPC Foundation, and this initiative is responsible for the development and the creation of specifications for extensions to the OPC UA technology to meet the various use cases and requirements for automation applications, including the field level. I want to first talk a little bit about some of the key challenges for industrial automation in the context of digitalization and the digital transformation. We still have today a quite strict separation between IT and OT technology. But it's clear that if we want to support the various use cases of, for example, Industry 4.0 or the Industrial Internet of Things, we have to exchange information across all these different levels inside a factory, inside a plant, and even beyond. And therefore, we have to come up with solutions that support the IT-OT convergence. What we also recognize is that today we have quite different solutions, different products, and even different technologies being used in factory automation and process automation. But certainly the requirements are quite similar, if not to a large extent identical. And this is why in future we have to strive for a harmonized approach that is not, let's say, distinguishing what kind of industry or what kind of vertical products or solutions are being used for. And probably one of the key challenges is the huge diversity that we have with regard to protocols and data models, especially when we look at the field level, because There we have all the different field buses and real-time Ethernet protocols. We have still digital analog interfaces. And looking then at the data modeling, we also use different device profiles just out of historical reasons. But this is all making the life complex and difficult, especially if you want to analyze data, if you want to derive certain strategies out of the information that you collect from the plants, from the factories. And this is why we have to come up with solutions that support the so-called semantic interoperability. Now, there are different solutions how to improve the vertical integration. I have here a graphic from the Namur Open Architecture, the NOAA, which is not dissolving the classical and established automation pyramid, but is adding a so-called second channel based on OPC UA in order to bring up information from the process, from the production, up to the edge and to the cloud. Even this is beneficial because existing solutions can be kept and the connectivity is improved by the second channel. At the same time, it's clear there are some disadvantages. You are adding an additional second channel, so the devices need to support an additional protocol, increasing somehow the complexity. And this is also only a unidirectional path from the process up to edge, up to cloud. Now, the approach of the OPC Foundation with the launch of the Field Level Communications Initiative back in November 2018 is to extend OPC UA to the field level so that it fully scales from the field up to the cloud, and not only vertically in both directions, but also supporting the horizontal integration, the horizontal communication. With this approach, OPC Foundation targets to convert the classical automation pyramid to a much more universal and flexible information network where you can have direct connectivity between devices and controllers and software applications, independent whether they are located in the field, in the edge, or even in the cloud. Now, OPC UA today is already used in many different application areas. You find here some examples listed with the numbers 1 to 4, secure remote access, local OT communication, and also, for example, cloud integration. The Field Level Communications Initiative is now extending the use cases to also cover controller to controller and controller to device, listed here with the numbers 5 and 6. And this is also including device to device. To support these use cases, the OPC UA framework is being extended with features and functions for field exchange. This is why we name these extensions OPC UA FX. And this includes, for example, extensions to support functional safety, to support real-time data exchange, including deterministic transport. It also defines features and what we call facets for motion control for remote IOs, and also the connectivity to field instruments. Let me talk a little bit about the initiative itself. The initiative is supported by overall 27 member companies that are part of the so-called steering committee. So these companies bring in additional resources, financial resources, but also manpower and the expertise. Browsing through the logos, you see that all the big players in industrial automation are supporting this initiative. So we have, for example, from the US, the companies Emerson, Rockwell Automation. We have from Europe the companies ABB, Siemens, and Schneider Electric. And looking to Asia, we have the big players out of Japan with the companies Mitsubishi, Omron, and Yokogawa. The technical solution that is being elaborated is supported by more than 320 technical experts that are coming from more than 65 member companies of the OPC Foundation. This makes us really proud that this initiative is getting such a strong support from the industry all over the world. Now, first of all, I want to highlight that in order to support industrial interoperability, you need to have standardization at all the levels that are listed here on the slide. So you need standardized network access, you need standardized protocol, and you need standardized data semantics. The solution for field exchange, OPC UA FX, is built upon existing OPC UA technology with the built-in security, with the information modeling, with the client server services and the publish subscribe extensions. The technical working groups of the FLC initiative are then extending the information models to support the various automation components, including offline configuration and including common behaviors, for example, to set up connections between the various automation components and to do the bootstrapping of a complete system. On top, we then have the various extensions and features to support the various application areas and the various device types. So there are facets for functional safety, for motion control, for instruments, for IOs, and so on. And the concepts are done in a way that existing device companion specifications can be integrated. So this is where we can, for example, integrate the PADIM information model or the MDIS or the DEXPI and all the other companion specifications that are elaborated through the numerous corporations the OPC Foundation has all over the world. Now, if we look at the lower levels, we are relying on various IEC and IEEE standards. Very important for us are especially the Ethernet standards out of IEEE, with the certain variants, for example, the Ethernet Advanced Physical Layer APL that is being launched in these days at the ACHEMA. Very important to bring Ethernet to the field in the process industry, but also Ethernet TSN to make transport deterministic is very important, as well as other communication standards that are being developed by standardization organizations. We are defining two communication profiles to map the information models on the higher layers to the underlying network and transport protocols. So we are supporting a UDP/IP protocol for a routable, flexible protocol, as well as supporting a so-called direct layer 2 mapping when it comes to a more efficient or highly efficient communication, for example, inside a machine for distributed IOs or high-speed motion control. The concept is also created in a way that we can easily adapt to other upcoming communication standards and technologies. Important to mention is especially 5G. We have established a cooperation with the 5G ACIA to support 5G inside the OPC UA framework to also support wireless communication. And in future, we will also extend to other wireless standards such as Wi-Fi 6, Wi-Fi 7. Finally, I want to highlight that we work on conformance tests for the various automation components in order to ensure high compatibility and a high level of interoperability across the various vendors. A key technology for OPC UA in the process industry is the advanced physical layer Ethernet APL, as already mentioned, because this is bringing Ethernet to the field even in hazardous areas. And because APL is transport agnostic, it is supporting different industrial protocols, including OPC UA. And this is why the OPC Foundation has become member of the APL initiative a few months ago to support the further development of the technology and also to jointly promote Ethernet APL with other standardization organizations. Now, talking a little bit about the current status of the project and the achieved results. The first specification release, the so-called Release Candidate 1, has been completed, consisting of 4 parts, parts 80 to 83. And these specifications are currently being used to do prototyping and to create test specifications as well as test scripts for the certification tool of the OPC Foundation. And furthermore, these specifications are laying the foundation to do specification enhancements for the additional use cases, controller to device C2D, including also device to device D2D in the next step. What I already can announce today is that we are currently preparing a controller-to-controller interoperability demo based on this RC1 specification release. The demo is planned for end of November at the SPS Automation Show in Germany, and we expect more than 15 vendors and more than 20 prototypes to be included in this controller-to-controller demonstration system, showing the exchange of process data, real-time data, even safety data between controllers of different manufacturers. Now, with this slide, I want to explain a little bit the migration path with OPC UA from existing systems to support in future also OPC UA in the field level. You see here the classical solution, having controllers that use OPC UA to connect up to the edge, to the cloud, to the MES ERP systems. And we have the field buses that connect the controllers to the various underlying field devices. Now, with the controller-to-controller specifications developed by the FLC initiative, we allow the horizontal integration and horizontal communication between controllers of different manufacturers. So this is the initial step. And then by bringing OPC UA down to the field devices with the use cases controller to device and device to device, we then have OPC UA as one consistent and one standardized interoperability communication solution that is fully scaling vertically as well as horizontally. Now with this slide, I want to quickly summarize the content of my presentation. I wanted to show to you how the OPC Foundation with its field level communications initiative is extending OPC UA to support also the field level. And with this approach, there is the possibility to finally convert the traditional automation pyramid to a very universal, to a very flexible information network where we can have direct connections between the various field devices, controllers, different software applications, independent whether they are located in the field, in the edge, or in the cloud. And the solution is to extend OPC UA to meet the various use cases and requirements in factory and process automation with the support of different underlying technologies and standards such as the Ethernet Advanced Physical Layer, Ethernet TSN, 5G, and in future also Wi-Fi 6, Wi-Fi 7, and whatever comes up. I'm now coming to the end of my presentation. I want to thank you all for your attention. In case of any questions, feel free to contact me. You have here my contact details, but you can certainly also look at the various links that I'm providing here to identify related material. We have brochures, we have recordings, we have slides available. So please have a look, and thank you very much again.
Hi, my name is Fengler. I live in Minden, Germany and work for ABB for more than 20 years. PADIM started 2017 by Fieldcom Group as a joint working group together with OPC Foundation. When starting, a team of highly engaged Fieldcom Group members driven by key process automation vendors like ABB, Amazon, Andres & Hauser, Yokogawa worked in close collaboration with end-user organizations like Namur, who provided use cases and requirements. OPC Foundation experts helped with deep questions concerning OPC UA technology. Goal is to standardize an information architecture for all process automation devices using OPC UA as a base and the DI model. Some definitions. Information model. Nested in hierarchical description of an asset including identification, diagnostics, process signals and configuration. Digital transformation. Using end-to-end digital systems to enable open information exchange and improve operational efficiency. IT-OT convergence. Removal of barriers to information access that advances operational effectiveness between process and IT teams. These definitions are important because they guide us through the whole presentation and are important to understand. IT-OT convergence. On the left-hand side, we see the traditional hierarchical automation pyramid, and with fieldbus hard proprietary fieldbus networks, devices are on the bottom, and on the top the systems and some added value applications. You see that there is a break in between so that you have to transfer data. Within IoT-enabled automation, the network is an Ethernet-based information protocol and, for example, APL as an advanced physical layer. On the top we have IoT-enabled devices and we have seamless integration up to value-added solutions which can work in the cloud. We have convergence towards IP connectivity, standard information model and semantic integration and plant-wide communication. Crossing the OT-IT chasm. OT understands automation protocols, fieldbus, device descriptions, DDs. Plant IT understands asset management, Ethernet and security. And the enterprise IT understands ERP systems, analytics, security. So everybody understands something in his domain. The problem is that data is lost in translation across systems. Electronically, information does not move through the layers. and also semantically, information moves, but meaning is misinterpreted. OPC UA is an enabling technology. And on this picture you can see the different protocols from, let's say, the recent years, starting with 4 to 20 milliampere, Profibus, Fieldbus Foundation, Modbus, Ethernet IP, and so on, and on which layer they are active. You see on the layer 1, there you have all protocols supported, but if you go the layers up to 3 to 4, you see that not all protocols are supported. But OPC is used through all these layers, and the OPC UA model for PA devices eases the IT-OT integration barriers. OPC UA provides modeling and integrated security by design. So this is an advantage for OPC UA to reach across all automation layers. Another enabling technology is Ethernet APL, Advanced Physical Layer. It is a high-speed 2-wire Ethernet and covers long distances. It has power and communication on the same wire and supports hazardous area applications, which are very important for process automation. Another important piece in the future of automation is the Namur open architecture. Namur as an organization would like to get more data for monitoring and optimization out of the plant and has therefore created a model to get access to all data for added value applications like condition monitoring, advanced diagnostics, and so on. Therefore, NOAA has created the NOAA information model. The key is that the Namur first thought about the use cases and then derived the parameter necessary for these use cases, and all of this is mandatory defined. PADIM is used to implement the NOAA information model with OPC UA. Crossing the OT-IT chasm. So what is necessary is Ethernet APL, OPC UA, and PADIM. That are the 3 important technologies which are necessary to cross the bridge. Field level communications, in short FLC, initiative of the OPC Foundation supports unified approach for factory automation and process automation. This slide shows how the structure for the levels is and provides as example a PA device, a process automation device, and a factory automation device. The differences are in the physical layer. The top layer is the same. On the very top layer, the PADIM and the motion are the difference that are the application for the specific devices. Now coming to the PADIM, Process Automation Device Information Model. Important points are semantic identification, defined signal variable types, and reusable interfaces. Coming first to semantic. What does semantic mean? Why is common semantic important? The guy on the left-hand side thinks about nice Jaguar. The guy on the right-hand side thinks, okay, what does he mean? A cat or a car? He thinks about a car. Okay? How do you find out what he is thinking? Therefore, a semantic description describes an object, the Jaguar. And this communication happens via symbols. The symbol is, in this case, the Jaguar. The Jaguar is, in this case, a physical object, but could be also an abstract object. So the symbol is related to an object. And the symbol has a reference to a description, where it is defined what the meaning is of this symbol. And this description describes then the object. And for that, the semantic ID, in short IRD, is used, and we call it also semantic triangle. So in principle, everything is clear, or? Why do we need a name? It's often the question. Think about there are not just one Jaguar, there are two. How you differentiate? The first one is called Oscar, the other one Bruno. And also with a car, you have license plates to identify the same Jaguar, but different instances, we call it in process automation. We have seen the picture on this slide already. Now I would like to provide you some more details. We have the protocol-independent OPC UA information model for process automation devices, and in the first step we provide it for pressure and temperature transmitters, for flow meters, for level transmitters, and for valve positioners. Future device types will follow. It standardizes a basic set of device information for identification, diagnostics, process variables, and core parameter. It implements the Namur open architecture requirements and maps the device information in a standardized way, including semantic information according to IEC 61987 Common Data Dictionary. It enables IT to access device information without knowledge of specific devices, and this is a harmonized information model with NOAA, with the Namur Open Architecture Information Model. As told, Namur started from use cases. That is very important to have always a use case in mind when defining an information model. And the first use cases which were considered are unique identification, which is very important to know which devices are within your plant. Automation is built to know, okay, what you have planned is also what you have built in the end. Dimension check, if you have a flow meter which is too large for the application, so you could reduce the size and reduce the cost. And some more use cases like device lifecycle backup, multivariable possibility check, or also device health, which is very important for diagnostics. Again, some very important definitions. A device. A device is a globally unique physical component identified with product instance URI defined by the manufacturer. This is often stamped on the outside of a device as QR code. Asset ID. An asset ID is a user-writable alphanumeric character sequence uniquely identifying a device. The ID is provided by the integrator or user of the device. Signal tag. A signal tag is a user-writable alphanumeric character sequence uniquely identifying a measuring or control point. A device can have several signals. As you see, the first one is defined by the manufacturer. The asset ID and signal tag are defined by the user. I have underlined the key words because that is very important for the information model to understand. Now, with the new information architecture of PADIM, we are supporting multivariable devices. These multivariable devices have not just one value to measure, they have multiple. For example, a temperature transmitter can measure 2 temperatures. On the left-hand side, we have the functional-centric model, which was used in the past, because in the past, often we had just a transmitter measuring one value. As we have today multivariable devices, we need another approach, which makes it simpler. We divide it into an asset and into signals. The asset defines the device with identification, diagnostics, administration parameters, and the different signals. Within the signal, you cannot just see the signal, the value of the signal. You can also configure it. So you have both functions together so that you, when you change the configuration, can also immediately see how the value is changing. There are some bullets in green and orange that are important for the next slide to see what is the asset and what is a signal. PADIM, this is now the detailed information model shown as a video drawing, and the green bullets show what belongs to the asset. The asset is reusing interfaces from the OPC part 100, the DI model. Within the DI model, there are interfaces defined for vendor and tech nameplate, device health, and these interfaces are reused in PADIM. But PADIM defines additional interfaces, for example, for administration and signals. Administration interface provides important things like a factory reset. And the signals provides the interface to the different signals of the information model. All of these parameters are defined in the IEC 61987 Common Data Dictionary with a semantic ID. Signal information model. That is very important, and that is an extension what we defined in PADIM to OPC part 8. We have defined signal variable types, which can be analog or discrete, which provide simulation, and which can be used at any object. In addition, we have signal type objects. These signal type objects use the signal variable types and provides also access to methods or the signal tag, the name of the value. If you need more information, go to fieldcomgroup.org/PADIM or to the OPC Foundation to download the specification, which is now released as version 1.0. Actions that you can take. Join the Joint PADIM working group. Thank you very much.
Greetings. My name is Nikolaos Papakonstantinou. I'm working at the VTT Technical Research Center of Finland, and I would like to give a short presentation about the DEXPI OPC UA companion specification. The DEXPI name stands for Data Exchange in the Process Industry, and is a group that was created to promote industrial data interoperability. Currently, its goal is to develop a specification for exchanging piping instrumentation diagram information based on the ISO 15926 standard between different software tools. The group itself consists of owner-operators, CAD software tool vendors, engineering companies, and research organizations that are supporting the development of the specification. The DEXPI file format is the Proteus XML based on the ISO 15926, but also with additional metadata that follow the DEXPI specification. These XML files can be imported or exported by software that supports the DEXPI format, but also act as an open data container for all kinds of applications that can find this information useful. A joint working group between the DEXPI and the OPC Foundation was established to create a companion specification that would enable the access of piping instrumentation data following the DEXPI format using OPC UA. This working group was led by VTT. In this way, information can be accessed in the same way as all other kinds of industrial information that support OPC UA, in that it can be open, unified, and standardized. Also, another use case is that we can potentially support the online collaboration on PNID design using tools from different vendors and the data on an OPC UA server. The companion specification is at release candidate status. It has gone through technical advisory committee review. We have fixed some comments and we are now addressing also some more challenges that has come up. But we hope that we have it soon available. Thank you for your attention. Do not hesitate to contact me for any additional information that you may need. Have a good rest of the seminar.
Welcome to the presentation LADS, Laboratory Agnostic Device Standard for the Smart Laboratory. My name is Birgit Ladwig and I'm head of the Analytical and Laboratory section of SPECTARIS and chairperson of the OPC UA Joint Working Group LADS. SPECTARIS is a German industry association representing, amongst others, the interests of 100 manufacturers of analytical and laboratory equipment. When we look into the laboratories of the present, this picture presents itself. Highly specialized devices, many different device manufacturers, various data formats, and above all, various device interfaces. In order to leverage the potential of digitalization, we need a communication standard for the analytical and laboratory devices. With our members from the analytical and laboratory sector, we took up the challenge of developing such a standard, which shall help to fulfill the vision, plug-and-play interoperability of lab and analytical devices along the laboratory workflow. The name of the standard is LADS, short for Laboratory Agnostic Device Standard. For LADS guiding principles. On a high level, we follow a use case-driven design and plug-and-play interoperability. We build on proven technology and copy with pride. This is why we utilize proven OPC UA standard features and companion specifications whenever feasible. Above all, and in order to master the challenge of heterogeneity, we follow the device type agnostic design principle. What did we achieve up to now? We founded an OPC UA Joint Working Group LADS in June 2020. Kickoff was in March this year. The technical working group will start its work next month. Together with BASF and further users from the chemical and pharmaceutical industry, we laid the foundation for LADS ERC, the LADS User Review Committee, which will start to work as soon as parts of the standard are developed. Also, we are in close contact with related initiatives like Allotrope, Bioforum, Animal and CELA. However, there is still a lot to do before the standard will be available for wide use, that what will be by the end of 2023. Who's behind LADS? Please find here the supporters of LADS. They are manufacturers, customers, academia, startups, and international multiplicators like our partner associations in Japan and Europe. Our working group offers various forms of involvement and cooperation within the network. Before coming to an end, I would like to thank the supporters of LADS, who not only support us with manpower and knowledge, but also financially. If you're interested in joining LADS or the Joint Working Group, please don't hesitate to contact us. LADS, bridging the gap, connecting the lab. Thank you very much.
Hello, my name is Paul Hunkar. I'm a consultant. I work for Yokogawa and for the OPC Foundation. Today I'm here to discuss MDIS. So what is MDIS? MDIS is an OPC UA standard for oil and gas platforms. It provides an interface between the topside controls and the subsea controls that are present on a platform. These controls are typically provided by multiple vendors, and the key challenge here always has been the integration of these two diverse systems. Operating companies wanted to standardize this interface, communication interface between the subsea gateway and the MCS to the DCS systems. Who is MDIS? MDIS is a grouping of major oil companies, DCS vendors, and subsea vendors. These groups are equally represented and worked on creating the MDIS standard. What was the goal of MDIS? It was to reduce the engineering and testing costs associated with these platforms. They want to do this via standardizing the interface and the information model. MDIS evaluated a large number of protocols. They chose OPC-UA as the best protocol for doing this. We've been working a long time on this. We've had a number of releases, so currently we're on release 1.03. We've had a lot of interoperability events to check and confirm and even showcase the functionality that MDIS provides. And currently there are quite a few projects out there utilizing MDIS. Provides a full information model. This includes support for object types, variable types, data types, and even methods that provide interaction between the objects. Some of the objects in MDIS are very customized to the subsea venue, such as a valve, which is a very slow, large object. It includes interlocking capabilities. It includes signatures and profiles that are needed for judging if the valve motion is correct. The MDIS specification also includes interactions between all of the subsea systems and valves. So this is the client and server interaction that's required. It includes redundancy. The other key concept in MDIS is the utilization of standard OPC-UA node sets. A node set in OPC-UA is an XML representation of the information model in a server. In MDIS, the servers are the subsea systems, and the clients are DCS systems. And this usually requires a great deal of configuration work, manual configuration work, to ensure that the DCS system has the same data and is looking at all the data in the server. The use of node set files, which are then consumed by the client tools, and auto configuration of the configuration for the DCS greatly reduces testing costs, greatly reduces engineering costs, because there are no errors for data entry. This is just what was provided. MDIS provides a full certification program via the OPC Foundation. This includes a complete check of the MDIS specification, all aspects of it. The MDIS organization defined test cases and provided test enhancements to the OPC Foundation CTT test tool, so that all the automated testing and scripting is available. This results in a certification logo from the OPC Foundation. Another key item in the MDIS specification is a recommended practice section. This is a section for the operators and how the operators should specify the MDIS or require the MDIS via a bid proposal. What items are included, what things can be specified, and what should be specified via recommendations. MDIS is also recommended by API 17F, which is the oil and gas standard specification. If you have any questions, please feel free to contact me.
Welcome to my short presentation of the companion specification for the Weihenstephan standards. My name is Christoph Nophut and I am the chairman of this joint working group. The use case of the Weihenstephan standards is the collection of information from machines in the process and production field of the food and beverage industry to run MES functionalities. So we cover three aspects. The first one is the definition of MES functionalities like efficiency analysis or batch and article tracing. From these MES functionalities, we derive the required data points that the different machine classes must provide. The third aspect is the communication interface. So with OPC UA, we'd like to establish an alternative to the existing WS protocol. The Weihenstephan standards are very domain specific. So at the moment we are covering 4 different domains. The first one was WS Pack for the filling and packaging industry. The second one was WS Food for the meat production. WS Baked was followed for the bakery industry. And our last domain was the process part of breweries with WS Brew. At the moment we are starting a new project for the definition of MES functionalities and data points for the chocolate industry. The Weihenstephan Standards Companion Specification uses 2 additional companion specifications. One is the companion specification for machinery, and we are using the building block for machine identification there. The second companion specification is the PACML one, and we are using the state machine for the machines there. To handle over 150 different machine classes, we decided to introduce WS templates. WS templates contains 3 aspects. One is the machine classes, the second aspect is the definition of the WS data points, and the third one is a permutation table between the machine classes and the WS data points. So you can get out of the WS templates and the companion specification your machine instance for all of our WS domains. In the Weihenstephan Standards Industrial User Group, a large number of companies from different industries are organized to continuously expand and improve the Weihenstephan standards. And our community is still growing. The Smart Production Systems Research Group at the chair of Brewing and Beverage Technology at the Technical University of Munich leads this working group. If you have any questions about the Weihenstephan standards, the Industrial User Group, or the companion specification itself, you are welcome to contact me or visit our website.
Welcome to the presentation on our OPC UA mining initiative. My name is Jan Lehmann, VDMA Mining, and I'm responsible for the organization of this initiative. I would like to introduce Dr. Fiona Mavroudis, ICOF Bergbautechnik, who is the chair of our International Joint Working Group. Mr. Tobias Hartmann, Institute for Advanced Mining Technologies of RWTH Aachen University, supports the development process of the mining companion specifications.
Creating a common specification or a common communication in mining is a huge challenge. This is due to the use of a variety of machines in many different processes and also in a list of environments with ever-changing conditions. Also, we do have many existing systems with lots of different communication protocols, or also have systems that do not have any digital communication at all. And these systems to be connected is the challenge we would like to tackle. How do we do that? We developed a process where we analyze the processes and the value chain in the mining environment that are of most interest for the producers and the manufacturers, and use the expertise in the working groups to analyze the processes and identify the information to be communicated and to be used to automate the process or supervise processes, and that we then integrate into our information models. Furthermore, we integrate existing standards into the information models to also be used in the OPC UA standard. Last but not least, we do document, of course, everything in the companion specification to be published. Our partner structure consists of over 60 participants from around the world, from Canada to Australia, that participate in the joint working group, that furthermore splits up in different groups of different interests, and that do work together to define the common language in the different applications. And all these groups are, of course, consisting of operators, OEMs, and are also supported by the academia. Furthermore, we integrate existing standards such as IRIDIS or fleet management standards, or even the GMG time usage model to be integrated into our companion specification.
So working on the OPC UA companion specification for mining, it's a great experience and will be an even greater pleasure to hold the first compliant product in your hands. We would like to close this presentation by inviting you warmly to join us. We're looking forward to welcome you in the joint working group to work together on the digitization of mining and connect the future. Thank you very much.
Hello, my name is Heiko Herden. I'm working at the VDMA, the Mechanical Engineering Association, and I'm the chairman of the OPC for Machinery Companion Specification Working Group. Today I want to talk with you about how to achieve cross-sector interoperability. We are coming from Industry 3.0, which is characterized by proprietary communication. Now OPC enables a meshed communication network, which is the first step to interoperability. The next step is to create information models which describe the exchanged data in a semantic way. This is done with OPC companion specifications. The VDMA and its member companies are very committed to the creation of those OPC companion specifications, as you can see on this slide. The VDMA is divided in several organization units, which are shown here. The ones marked in orange are currently working on companion specs, and the ones marked in blue have already released such a document. In conclusion, we have about 35 working groups currently working on OPC companion specifications. These efforts lead to domain-specific harmonized information models. But the king class of interoperability is to have cross-domain harmonized information models. And this is done in OPC for machinery. So, let's take a look at OPC for machinery. What is it? It is a companion specification for the whole mechanical engineering industry. This means that it applies for machines like injection molding machines, robots or woodworking machines, as well as components as pumps, scales or electrical drives. OPC for machinery defines basic building blocks for the broad use. Each building block stands for a specific use case, such as machine identification or machine state. The machinery spec or single building blocks can either be referenced from other companion specs or be implemented as a standalone model. So you could say that OPC for machinery forms the basis for interoperability. Now let's focus at those building blocks. We started with machine identification, which enables a unique identification of the machine with properties like manufacturer and serial number. Then we proceeded with component identification, which is pretty similar to machine identification, but designed for components. And furthermore, we have the released building block listing of machinery items. This is needed when you have an aggregating OPC server with several machines connected, because then you can see all of those machines in a single folder, at least the machines that have the machine identification implemented, and also you can take a look into the machine and see all the components which are part of the machine, at least if they use the component identification. And then we have the upcoming building blocks. The next building block to come is machinery state, which will provide information whether the machine or component is currently running, idle, or out of service. And we also started to work on the use cases of job management and result transfer. If you take a look at the picture at the bottom, you can see that all VDMA domain specifications will be using the VDMA base spec, which is OPC for machinery. Okay, I'm at the end of my short presentation about OPC for machinery. Thank you very much for listening. And if you have any questions, feel free to contact me. You can download the OPC for machinery specification at the OPC Foundation homepage or at the homepage of the VDMA. Thank you. Bye-bye.
Hello and welcome with the OPC Foundation. It's a pleasure for me to announce our next guest. It's a personal pleasure for me because I know Peter Seeberg for years. But for a starter, Peter, please introduce yourself. What is your job? And how do you have come to work with artificial intelligence? This is our topic today.
Oh, certainly, Stefan. Thank you very much. Yeah, my name is Peter Seeberg. I was born and I studied computer aided design in Delft. That's in the Netherlands. I've worked about 25 years in IT, most of the time with Intel, but also for a number of software companies. And about 10 years in industrial space, mainly discrete, but also process automation, which is the time that I've come across OPC UA technology. And as you just mentioned, you and I, together with a couple of other folks, we've been traveling around the world and making OPC UA known to the world. So I've dealt with introducing AI, artificial intelligence, into industrial space for the last 10 years. And I've been an AI consultant for 3 years now. I live in the Munich area. I write books on artificial intelligence, and I co-produce a number of podcasts on the topic of AI and also OPC UA.
Yeah, definitely good times we share together. So since when exactly does artificial intelligence exist? Was there a specific starting day? And by the way, is there a specific definition and rule for what we can call artificial intelligence? And isn't it just a normal algorithm which is helping us to do our job?
Yeah, the term AI exists since a long time. Actually, the 1950s, it was first used by a guy called John McCarthy in an invitation for which was a 2-month study of artificial intelligence, and that was carried out during the summer of 1956 at Dartmouth College in Hanover. That's not the Hanover we know in Germany, the famous Hanover Fair, but that's the Hanover in New Hampshire in the United States. And he talks about, and I quote, every aspect of learning or any other feature of intelligence that can in principle be so precisely described that a machine can be made to simulate it. So that is, let's say, the rules-based approach to AI. And 3 years later, that was 1959, there was another guy called Arthur Samuel, and he defined the term machine learning. And that is today's most important way of doing artificial intelligence. And I quote again as the field of study that gives computers the ability to learn without being explicitly programmed. And let's call that as the probability-based approach to AI. And then there's a third important person to mention, that's Alan Turing. Many of you have heard about him. And he already in the 1950s, he asks, can machines think? And what he does is he develops a game which since then has been known as the Turing test. And the Turing test is there to help decide if algorithms show intelligence. To conclude, today we do not have a single definition of what is AI, but that's not really different from having not a single definition for what is intelligence. One important differentiation that we can make is between weak AI and strong AI. The latter is representing algorithms at some point in time in the future, reaching the same level of intelligence as humans. And that's a concept which is targeted by, I would say, a small group of worldwide researchers. And on the other hand, we have weak AI. It's representing algorithms that can do all kinds of things for us humans, good, but also evil. And at the same time, this is the basis for my personal definition that has worked well for the last couple of years, being algorithms as a tool in the hands of humans that recognize patterns in data that are too complex for humans to recognize. And they support us in our daily lives, hopefully doing good things, but sometimes also bad things.
So indeed, very interesting, Peter. So is artificial intelligence then more a threat or is it an opportunity? This might be very emotional for a lot of listeners.
Good question. I guess that most of us have heard about the results from various researchers in the field in the last couple of years, actually, saying that whatever 50% maybe of jobs will be taken over by AI, and on the other hand, creating more or less new jobs that did not exist in the past. As a global community, we could decide to deal with AI if that was what we wanted, let's say similar to dealing with climate change. Now, as far as AI is concerned, the opportunities are so huge that many countries, not only the United States, China, also Europe, all of them would like to play a major role, a global role in being or maybe becoming an AI powerhouse. Each of them more or less regulating AI for the good of business, the party, or the people, depending on what part of the world we're in. So for what we are together here for today at ACHEMA, AI is to be considered as a huge potential, I would say, for bringing the process industry to a new level of products and execution. So what I would like to suggest to any listener is that your job, whatever your role is today, will change a little or a lot. And my suggestion is don't wait for AI to take away or change your job. Instead, sit together with your manager and agree on what it is that your parts of your job are going to be taken over by AI in the near future. Maybe just slowly phase out of them, let them go, and agree on which are going to be the new activities that you will be in charge of instead. And then also agree on the training, on the continuous training that you shall receive for the upcoming years to get into your new job and manage your new activities in this world of AI.
I'm hearing you and your call for us human beings as we should see it as an opportunity here. Okay, good. So please, can you give us some more examples of real use cases of artificial intelligence in the process industry?
Yes, without going into much detail, because any of the listeners can do that by me saying that I recognize two major, I would say, categories of AI in process industry, which are optimization on one hand and new product development on the other hand. So let's start with optimization. Depending, or let's say independent of the listeners having a problem, maybe not reaching your target quality, downtime, or throughput numbers, whenever we humans, we cannot find further improvement of such efficiency indicators, machine learning algorithms may find patterns in your data which are too complex for us to recognize, and they may result in less downtime, higher quality, or more finished products per time unit. Specifically, so-called process mining technologies, they can help you trace back original situations in complex processes that cause problems further down the line. And after finding such problems, you will then decide, if it's only a small thing, you may want to make just one or the other engineering change. So, although of course process industry is kind of complex, but maybe then a week or a month later, everything will be working fine if it's a small thing. But I would believe, and my experience says that more typically, if the issue at hand is like a large thing, you may rather want to place a digital model in or close to your plant. That means that algorithms will be looking for similar situations to occur in the future. And they will handle, at least with a yellow, orange, or red light on the control panel, or maybe automatically change, deviate from the standard process in order to, for example, prevent the plant to come to a standstill. So future plans, they will contain any engineering changes, any updates, and specific machine learning approaches, for example, so-called reinforcement learning, they will help you come up with structurally new process approaches, and they will also help you design new products. So humans can pick and choose one by one a potential solution, maybe out of 1 million or 1 billion space of possible solutions. And then we can have a team spend a week or a month or longer before reaching to a positive, but also normally a negative conclusion. Now, on the other hand, reinforcement learning can have agents test in that same space of millions or billions of potential solutions, and they can do that on the basis of predefined criteria within days.
Okay, thanks. So what I learned is that first of all, the process is to collect a huge number of data, to then start the process to analyze these data. Obviously, I have to ask, what is then the role of OPC UA to collect these data? Because first you need connectivity to the plant, to the assets, to collect all these information. So what role is OPC UA in combination with artificial intelligence here?
Yeah, thanks for asking. And I really can only say that for me, OPC UA and AI are like a winning team. And we're going to explain you why I believe that. The typical way to go about introducing AI independent into what area you do so. Let's say, so talking about machine learning into your plant, you would start doing an assessment. Maybe you do a workshop, you do some brainstorming, you're going to see what use cases do we have at hand, do we have data, what's the quality of the data, and then you're going to have to define some goals, what it is that you want to reach with introducing AI. And at the end of maybe, like a day workshop, at least you should agree within a team of persons the top 1, 2, 3 test use cases. And my guidance would be to start small, to go for a step-by-step execution. Don't try to solve the world's problems just from the beginning. Do it step by step. So then, if you then say, okay, now we have a 1, 2, 3 priority use cases, do a proof of concept on number 1. So maybe a POC for 3 months or 6 months, depending on the scope. Now, let's say you go for the 3 months POC. What you need to know is that typically, and you can ask really any data scientist for their experience, the rule is that about 80% of the work done by the data scientist is about cleaning, also called cleansing the data. So first you're going to have to find data, and typically, as most of you listeners know, you will find the data in many different departments, silos, responsibilities, not that easy. Then you need to understand the data. What are the variables? Because of the lacking information, you need to go and find somewhere a report. You need to fill in the missing data points, etc., etc. So until you have a clean data set, that you then have a high expectation that algorithms are going to find patterns in them and help you solve your problem and reach your goal, within the 3 months, the 12 weeks that you have, you will have already spent 9 weeks finding and cleaning the data. Now, with OPC UA in your plant, you can almost immediately start applying AI algorithms on the defined variables in the information model. So, day one that you start doing your job, first thing you will do is you're going to look at the OPC UA information model, which, because it has been an integrated structural element in the running plant, the information which you will find there, is up to date, and you have all the information available at your hands, the data points, the variables, the relationships, and you can start right away maybe choosing what part of the information, so what data, what section of the model you're going to be using for your POC, and within the hour, you can feed your data into the machine learning algorithms. So as a close, here you are, 3 months time available on day one, where you would normally be after 9 weeks, or maybe even further, because even after the 9 weeks, you could find out you don't have any relevant data. Not so with OPC UA. So I can really only say, as far as I'm concerned, OPC UA is the perfect match for making AI come true in the discrete, or specifically in this case in the process industry.
Okay, Peter, that's a very promising win-win situation for OPC and artificial intelligence. Interesting that there are so many flavors and of OPC and the benefits. So some people think, okay, I can protect my data. I'm able to exactly configure who is able to read and write my data, and I want to own them. Some of them I want to share, and so the security aspect is given for them as one of the biggest benefits. Here we learn for artificial intelligence, it is to have data in a specific context, that we have a meaning of the data, so we have better information, and I learned we can save a lot of time here. That's definitely great news and good benefit. So, Peter, it was a pleasure to have you as my special guest here today. Again, I recommend to our listeners the books from Peter. He's a dedicated expert on multiple presentations here in Germany. Peter, thank you so much for your time. And for the listeners here, please stay tuned and follow other sessions. Thank you. Bye-bye.
Thank you, Stefan. It was great to be part of the show.
Hi folks, my name is Erich Barnstedt. I'm the Chief Architect for Standards and Consortia in Azure IoT, and today I want to talk to you a little bit about how to avoid vendor lock-in and a practical guide and how to achieve that. So, first of all, you're probably familiar with vendor lock-in. It happens when you're forced by one of your suppliers to use a closed source SDK or some sort of proprietary interface that they make available to you. Sometimes they only allow you to communicate through a proprietary communication protocol. Sometimes there's the data model or the data format that is proprietary. Or then, more subtly, sometimes there's a certain number of data centers or, on-prem assets that you need to purchase that are mandatory for running the software, right? And then, of course, if any of that happens, you'll be locked into that vendor forever, right? Until you switch off the solution. So how to avoid it and what you need to, really require from your vendor for this to not happen to you. So first of all, obviously we're here on OPC Day. OPC UA is the industry interoperability standard that Microsoft's been supporting from the start, and we've been putting OPC UA into our Azure product since 2016. And the reason why we think OPC UA is so important is because it gives you interoperability, gives you an open, extensible data model, and best-in-class security, which is really important also when you're talking about cloud applications. And regarding the data models, I mean, there's bound to be a standardized data model for your industry out there already, because there's so much momentum behind building these data models right now. So really, no matter what industry you come from, chances are there's something out there already, and all of them are available free of charge from the OPC Foundation, website and the specification that is, and the data models themselves are on GitHub, so you can just download them. Here's one from the oil and gas industry. As some of you may know, I'm currently involved in a carbon capture and storage project with some of the largest European oil and gas companies. It's called Northern Lights, and one of the data models we're looking to leverage is this MDIS data model. And as you can see here, there's going to be a pipeline of CO2 sent to the sea floor, and it's going to be pumped by something like this device here underground and stored forever in a safe location for permanent storage. So it's quite an interesting project, and of course we're going to leverage OPC UA for it. So there's so many consortia out there, and every time I blink there seems to be a new one. It's kind of hard to really get a feel for who they are and what they do. So in general, when it comes to industry 4.0 or industrial IoT in Europe, there's the Platform Industry 4.0, which started in Germany but is now really a European initiative. And there's a number of input organizations that feed into the Platform Industry 4.0, and the OPC Foundation is one of them. Right, here are the others. And then the platform creates a reference architecture and makes recommendations on how standards from the input organization should be leveraged. And then there's a number of user organizations that leverage some of the standards that the platform recommends. And the most popular ones here are Namur, Umati, now also Gaia X, the Labs Network, the IDTA, and the Industrial Data Space Association. So they're getting a lot of press right now because they're making some big strides into leveraging some of the recommendations, architectures, and standards from the Platform Industry 4.0. So what does that mean in terms of standards for the Platform Industry 4.0 reference architecture? Well, OPC UA is mandated as the information model and the communication infrastructure for client-server communication. Towards the connected world, towards the cloud, OPC UA has been extended in 2017 with PubSub. So the area in gray here is now PubSub. The asset administration shell is something that the Platform Industry 4.0 has been driving for a number of years. It's really a container format and a data sharing service, right? Of course, because OPC UA is mandated by the platform, there's a mapping to OPC UA available, and the trick with leveraging the asset admin shell with OPC UA information models is that the information model should stay intact. So really, how to achieve that, you can find a sample that I built on my personal GitHub account here, github/Barnstedt, and you'll see how to leverage that. So the trick is really to keep the OPC UA information model intact as you transfer that information model from one cloud to another, from one vendor to another along the industrial IoT supply chain. Okay, so in terms of practical guide, really, you got to ask yourself 5 questions. If you can answer those 5 questions, you will be successful, or you have a better chance of being successful in your industry 4.0 project without getting locked in by your vendors. So I'll go into those questions now one by one and give my opinion of what is important when you're asking these questions to your project lead and then also to your vendor. So really, question number 1, what data model will you pick, right? So really people talk about data being the new oil. It's not the data, it's the data model that's the new oil. If a vendor dictates a certain data model, which is most of the time proprietary to that vendor, you're getting locked in, and you want to avoid that, right? So really, you know, demand IEC standards for your data models. OPC is such an IEC standard. And I also find, you know, lots of people talk about their technology as being standard or standards based. Be careful there. If it's not an IEC standard, it's not a standard. Or, you know, there's other standard organizations. OASIS is also a standards organization. DIN is a standards organization, but, you know, for example, the Eclipse Foundation is not a standards organization, and lots of people contribute their technology to the Eclipse Foundation and claim that it's a standard. It's not, right? Be careful there. Also, what happens a lot is that you get asked to remodel your assets in the cloud, right? So again, that's a telltale sign that you're getting locked into a proprietary data model. Don't do it. Demand that, you know, you can leverage your existing standards-based data model or model your assets using a standard and then demand support for that standard, right? Worst case, right, if the vendor says, you know, I can't redesign my entire product, ask for an import tool at least. So you can leverage your existing standard and then, you know, import your standard based data model into whatever service that the vendor offers, and then also demand to get the data back out when you want to, right? So kind of standard data in, standard data out, right? So that's number one. Number two, where do you want to normalize your data? Well, guess what? When you're doing cloud analytics, you'll have to eventually normalize all your data into a single format, right? A lot of people think as long as I can send the data to the cloud somehow, it doesn't matter how, I'm done, right? Problem solved. No, it's not. That's where your problems start, right? So you want to convert your data preferably to a standard-based format as soon as humanly possible. The best place for that to happen is at the edge before you even send it to the cloud, because, you know, the edge is usually per production line or per plant, part of a plant, and then, you know, you don't need to scale to the massive scale that your cloud application will have to scale to when you're connecting all your assets, all your plants, and all your factories to the same cloud, right? So that is definitely a better place to do it. You know, and again, formatting that data once is the key. And it's also usually a lot easier to find somebody who actually understands the data locally on the factory floor, right, or in the plant, rather than getting some of your IT folks to make sense of the data in the cloud later on. Question number 3. What telemetry format will you pick, right? So, you know, if I had a penny for all the times that some sort of industrial IT expert has, you know, talked about their latest hip and trendy discovery regarding, you know, a super efficient format and how they've tried it out on a Raspberry Pi and it worked great and all this, just don't believe it, right? Really, the most efficient way of sending data long term is by using a standard format, because it gives you interoperability, right? And you also have a good chance that the data format will be supported natively by the services and cloud databases that you're going to use. Because really, if you're sending the data in some other format and then you need to you know, re-encode the data in the cloud, again, you have to pay for that re-encoding, right? And it adds no value, right? Best case scenario, you're converting the data into a standard format on the edge, and that format is natively supported by your cloud application. That's why OPC pops up as such a good format, because it you know, defines a standardized JSON encoding, and every single service and database in the cloud these days supports JSON. right? That is a huge value saver right there, or cost saver. Okay, next question, how much scale do you need, right? So, you know, a lot of times people, you know, pick their projects too small or too big, and then they run into problems. So the best thing to do is to start small, start with a small POC and then scale that out. And the trick is to use services in the cloud that auto scale, right? If you need to basically keep an eye on your services all the time just to make sure they don't run out of juice, that's not a great job description, right? So you want to be able to auto scale those services if at all possible, and figure out the use case before you start building an architecture, because a lot of times they built, you know, folks built this massive architecture and then, you know, they end up not using it, and, you know, because their use case is much simpler than they thought. Then the next one, do you need to integrate third-party enterprise systems? Most of the time that answer is yes, right? So you really need a separate mechanism for those additional asset telemetry streams. You know, historians are notoriously hard to connect to because they usually have a proprietary interface. Thankfully, there's OPC Foundation partners like Matricon and Softing that have connectivity software for those proprietary interfaces. They also, you know, obviously offer an OPC way interface on the back end, so you can connect through OPC way to those software assets, and it makes it much simpler than to, again, do that data standardization. Similar with ERP systems, they usually have proprietary interfaces, and you just need to bite the bullet and create a converter, right? Extra points for converting into a standard format. So then those were the 5 questions you should answer, and just, you know, just bear with me here because I get this all the time and I can't say it often enough. This whole OPC way versus MQTT makes no sense, right? So OPC way is platform and protocol independent. It has a mapping, you know, to MQTT. That mapping existed for, you know, 4 years now. It's part of the IEC standard, OPC way, and, you know, we're going to continue to leverage more features of MQTT as they become available. For example, MQTT v5 has a few extra features regarding routing and so on, and of course OPCUA is eventually going to make use of that. So, you know, this whole efficiency conversation comes up from time to time. We've been using OPCUA PubSub with MQTT since 2015 for the last 6 years, and we found it very efficient at Microsoft. It's also very cost effective. So, I mean, don't believe everything you read, you know, on the internet. If it's on the internet, it must be true, right? So anyway, don't believe it. It's very efficient, and, you know, we've been leveraging it in a lot of large-scale customer projects very successfully. So what does the Microsoft Industrial IT Stack looks like? So nothing's really changed there. Most folks that know me have seen this slide before. So, you know, our cloud is split up into layers. So at the bottom, you have your infrastructure, your, you know, databases come on, you know, one layer above as PaaS services. So managed services, Microsoft manages those services for you. Then on top of that, we've built our, you know, super efficient interoperability layer based on OPCUA, and that's the OPC Publisher, the OPC Twin, and all the other OPC services that you're probably familiar with by now. And then on top of that, if you want a turnkey solution, we also have a software as a service offering now, which is IoT Central. Time Series Insights has its own dashboard. Power BI, obviously no code dashboarding functionality. So if you want just to log in and start, you know, playing out of the box, you can do that too. And as a partner, you can build on any of those layers. You know, every single one of them is optional. So you can base your own industrial IoT platform on our infrastructure if you want to, or you can, just reuse some of the higher level services. In general, end users want, managed services because they don't want to manage those services themselves. And, Microsoft takes pride in actually, doing a lot of the and keep extending the services that we offer, and creating new services that we manage. So what does a normal industrial IoT data pipeline look like, which leverages OPC-UA? Well, here it is. So you have your assets on the left. They could be aggregating assets, so several physical assets connected to one aggregating asset using an OPC-UA server. Then you have some sort of edge gateway. We have IoT Edge, of course. Then we have the cloud gateway, which we call IoT Hub. And then we have our time series database, which is called Azure Data Explorer. And this entire pipeline up to and including the time series database is based on OPC-UA pub sub, and it can understand that data natively, no data conversion required. And then, of course, you can connect your machine learning or Synapse to that database and do some predictions, write some Azure functions, which is a serverless compute service that we offer, and then even create a digital feedback loop based on IoT Hub methods. And those methods are then translated back to OPC-UA method calls on the edge. And unfortunately, still almost everybody else, not everybody else, but almost everybody else doesn't do that. They still leverage OPC-UA just to collect data on the shop floor and nothing else, which I think is a shame because, again, it doesn't leverage open standards and locks you in. So there's a separate talk on this topic, so I'll just briefly mention it here. We have this thing called the UA Cloud Library, which is kind of the missing piece in this entire telemetry pipeline. It allows you to upload OPC-UA information models to the cloud and leverage them, read them on demand as you're doing your analytics, which is kind of handy. So your time series data can be just the time series data, and to look up the information model that is associated with that particular time series, very soon you'll be able to leverage the cloud library. So we're working on releasing the spec. It's in draft. It's in review right now with the OPC Foundation, and hopefully we'll be able to release it soon. And then, we've also started some POC prototype implementations of it already. And of course, we're going to open source them, and you can make use of it then. So very briefly, you should be familiar with this. So we keep growing our brownfield connectivity partnerships with additional partners that are leveraging IoT Edge and building OPC-UA enabled connectivity solutions containerized on IoT Edge. Here's a list, and again, they're on the Azure Marketplace. So in terms of very basic connectivity, you don't need a lot of services at all. Edge is free, OPC Publisher is free. You can leverage the connectivity adapters I just mentioned from the Edge Marketplace, and then all you really need is an IoT Hub. In terms of condition monitoring, you don't need much more either. You just really need an app service instance that hosts your dashboard. We're going to release a new OPC-UA enabled dashboard next week at ACHEMA Pulse. And then if you want to do predictive maintenance, Azure Data Explorer does that for you. It's a managed service, and I've recently blogged about how to leverage that with OPC-UA data. It's linked there on LinkedIn. Okay, so the entire architecture, including what is required for building a digital feedback loop and machine learning and all that, is here. Just nothing's really changed there. We've been using this architecture for the last several years very successfully in lots of projects. So it's there for you to use, but again, start small and then gradually build up your architecture as you need it. So really, to sum up, step by step, we support at every step, and we have the services available to make that happen without locking you in to you know, the Microsoft ecosystem. So that's the key for today. Thank you very much for listening.